Yo guys, sup? This video is going to look at calculating empirical formula. So the empirical formula can be calculated from the percentage composition by mass of a compound. So here I have 4 steps you should take in order to calculate the empirical formula. The first one is from the percentage, find the mass of each element in 100 grams of a compound. So normally in the question it's given to you as percentage, but ignore the percentage and just work with it as mass or grams. So let me say you're given 73.9% of an element. Ignore the percentage and just work with grams. So 73.9 grams for mass. So it's simple as that. And secondly, you need to find the mole first before you find the empirical formula. So divide the mass by the molar mass to get the mole. So which by this formula, mass divided by molar mass. So after finding the moles, inspect your answers and then find for the value which is the least. So divide all the amounts by the least or by the simplest whole number ratio. So after you get done with that, remember empirical formulas cannot be placed in decimals. So you cannot have something like 1.5 to 3 to 1. So it has to be in a whole number. So you have to multiply it by the multiplication factor. For example, here is 1.5, which is the same as 3 over 2. So multiply by 2 to get a whole number, 362. So if you multiply everything by 2, this is what you will get. Yeah, so let's look at some examples. So our first example is the percentage composition by mass of aluminum chloride is 20.3% aluminum and 79.9% chlorine. So determine the empirical formula of aluminum chloride. So aluminum is given to us as 20.3% and chlorine is given to us as 79.7%. Remember what I told you. So just assume the percentages are equal to the mass. So it's the same as 23 gram and 79.7 gram. So once you have that, the next step will be calculating the mole. And how do you calculate the mole? By using N is equals to mass over molar mass formula. So for aluminum, the mole will be 20.3 gram divided by 26.98 gram per mole. So for the mole of aluminum, you will get 0.752 mole, and for chlorine you will get 79.7 divided by 35.45 equals to 2.25 mole. So after this step, the next step will be dividing the moles by the smallest ratio or by the simplest ratio. So that will be 0.752 divided by 0.752 because that's our smallest. It's 2.5 greater than 0.752. So, and also 2.25 divided by 0.752. You'll get 1 for this obviously, and then if you divide this you'll get 3. So since we find our simplest ratio or empirical formula, the next step will be just writing the empirical formula. Since aluminum is 1 and chlorine is 3, so it will be aluminum chlorine 3. So we're done. This is our empirical formula. And the second question will be finding or determining the molecular formula from the empirical formula that we found. So the molar mass of aluminum chloride is given to us as 267 gram per mole. So, and the formula we have found in the previous slide was aluminum chloride 3. So we need to find the molar mass for the empirical formula before we can find the molecular formula. So For aluminum, we know the relative atomic mass or the molar mass for aluminum is 26.98, and plus 3 times 35.45, which is for chlorine, and 3 because the subscript is 3 here. So on your calculator, this will be 133. The next step will be dividing the molar mass of aluminum chloride by the empirical formula molar mass. So we do something like this: 267 divided by 133. So that will give us 2. So in order to get the molecular formula, what we need to do is multiply the empirical formula by the value you got. So that would be 2 times aluminum chlorine 3. So that would be like aluminum 2 chlorine 6. So the way we can test our answer is, so if I want to find the empirical formula, remember you have to divide by the smallest ratio. So that would be like aluminum chlorine 3. So we go back to where we started. So that means our answer is correct. So we have percentage composition by mass. So what's percentage composition? So percentage composition is equals to mass of element in compound divided by molar mass of a compound times 100%. So let's put this formula into practice. So we have an example here, right? It's C6H12O6, and we're supposed to find the percentage by mass of carbon in glucose, C6H12O6. So what we need to find, since it's carbon that we are asked for, so it should be percentage of carbon in C6H12O6 or glucose. So that would be molar mass of carbon divided by molar mass of glucose. So let's find the molar mass of carbon first. So the molar mass of carbon will be 6 times 12.01, because the molar mass of carbon on the periodic table is 12.01. So that will be 72.06, and the molar mass of glucose will be 6 times 12.01 plus 12 times 1.01 for hydrogen, and plus 6 times 16 for oxygen. So that will give us 180.18. So the next step is easy. Just put these two values into the formula and then you find your answer. So that will be 72.06 divided by 180.18 times 100%. So that would leave you with 39.99%. So carbon makes up 39.99, which is close to 40% of glucose.